Next, I want to show you about a couple more rules for derivatives. In this video, we're going to prove the constant multiple rule and the sum and difference rule, and use these rules to find the equation of a tangent line. Now, there's a couple things that we already know about derivatives. We know how to find the derivative of a function using the definition, and that was the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. And we know how to find the derivative at a specific point, a. That would be the limit as x approaches a of f of x minus f of a all over x minus a. From those, we developed a couple of basic rules. We know that the derivative of a constant is always going to be 0. And we also have the power rule as well, that if we have x to any sort of power, we just bring the power down as a coefficient and then reduce the power by 1. So we can find these derivatives quickly. We know that the derivative of 4, since it's constant, is going to be 0. Make sure that you call that the derivative when you're doing your work. I mean, just using prime notation or dy dx notation, both will work, but be able to distinguish between what the function is and what the derivative is. So if our function is x to the 7th, then our derivative is going to be where we bring down the power and then reduce the power by 1. When we have functions that are written as a rational function or as a radical function, it's a good idea to rewrite that as a power. Then we can use our power rule to differentiate. And g prime of x is going to be bring the power down, -1, and reduce the power by 1. So -1 minus 1 is -2. If you would like to rewrite that as a radical function or a rational function, -1 over x squared. For h of x, since we have x times the square root of x, that would be x times x to the 1/2. Putting those two together, that would be x to the 3/2 power. So our derivative is going to be bring the power down, 3/2, and then reduce the power by 1. So if we take 1 away from 3/2, we're left with 1/2. And if you want to rewrite that as a radical function, that would be the square root of x. Now, what we haven't done is dealt with a function that looks like 5 times x to the 7th power, where there's a constant being multiplied by that function. We probably have an idea of what we think the derivative will be, but we can't go with that until we prove it. So let's let c be a constant and f of x be a differentiable function. And we want to find the derivative of c times f of x. Now, we're going to have to resort to our definition. And since we're trying to find the derivative of a function, I'm going to go with delta x approaching 0. And my function is c times f of x. So plug in the x plus delta x first, and then subtract off c times f of x all over delta x. Now, since each term in the numerator has that factor of a constant, I'm going to factor that out. So we'll have a constant times f of x plus delta x minus f of x all over delta x. Now, when we start taking the limit of the constant is going to be the constant. And that's because we're taking the limit of the constant, not the derivative of the constant. And then we'll still have the limit as delta x approaches 0 of our big ugly fraction. But our familiar big ugly fraction, we know that this fraction is the definition of the derivative. So we will end up with c times the derivative of f of x. In short, we just proved the constant multiple rule, that if we want to take the derivative of a constant times a function, we can just take a constant times the derivative of the function. So when we want to find the derivative of y equals 5 times x squared, that's 5 times the derivative of x squared, which was 2x. So that will simplify to 10x. And we have y equals negative 2x to find the derivative. Right now the power is 1. Basically, we bring that power down and multiply by our coefficient, and then reduce the power by 1. So that'd be negative 2. And our last one, y equals 7. Well, derivative of constant is 0. So what do you think is going to be the derivative of y if y is equal to 5x squared minus 2x plus 7? Your instinct probably telling you y prime is going to be 10x minus 2 plus 0 when we just add together all of our derivatives. Well, we're not sure about that yet until we prove it. So let's take a look at two differentiable functions, f and g, and what would be the derivative of f plus g? Well, we would have to use our definition of the derivative, which again is the limit as delta x approaches 0 of f plus g of x plus delta x minus f plus g of x all over delta x. Now, we know with that notation of f plus g of x that we can split that up into f of x, so f of x plus delta x, plus g of x plus delta x. Then we're going to subtract off f plus g of x, so subtracting off f of x plus g of x all over delta x. We can rearrange a little bit. Like, I'm going to put the f's together. So we'll have f of x plus delta x, and then subtract off f of x. Then we'll have the g's together, g of x plus delta x, and subtract off the g of x. All right, now I'm going to do two steps at once. I'm going to take this larger fraction and split it into the sum of two separate fractions. And then I'll take the limit of each of those. So my first fraction, the limit is delta x approaches 0 of the f's. So f of x plus delta x minus f of x over delta x. And then my second fraction, take the limit as delta x approaches 0 of the g's. So g of x plus delta x minus g of x all over delta x. And each of these should be familiar that when we're looking at that limit of the f of x plus delta x minus f of x over delta x, that's the derivative of f of x. And our second limit for g of x plus delta x minus g of x over delta x is the derivative of g of x. And what we just proved is the sum rule. Now, without loss of generality, we could have gone through and changed all of these pluses into minuses. And along the way, that would have changed all of these into minus. And as we work our way through the proof, the only thing that's really going to be changing, those change to minuses, which is going to make this one change to minus, this one change to minus, and this one change to minus. So we have the sum rule as well as the difference rule here, that if we want to find the derivative of f plus g or f minus g of x, we just take the derivative of each term. So we would find the derivative of f of x, either add or subtract the derivative of g of x. Which is encouraging. It means that our instinct on that last problem was correct, that we can just find the derivative of each term along the way. So let's write the equation of the line tangent to f of x when x is 4. Remember that when we're trying to write the equation of the line, we need two things. We need a point and a slope. So the first thing I'm going to find is a point that is on this curve. I know that I want to find the equation of the line tangent when x is 4. So my point of tangency is going to have an x coordinate that's 4. And we need to find out what the y coordinate is. So we're just going to take that and plug it into f. So 3 times 4 to the 4th minus 2 over 4 plus 7 square root of 4. And I'll save you from watching me simplify all of this down, but it should simplify to 781 and a half. So that will end up being our y coordinate. Next, we need to find the slope of our tangent line, which of course is going to be the derivative. Before I find the derivative, I'm going to rewrite our original function as a sum of power rules. All right, so we'll have 3x to the 4th, then we'll subtract 2x to the negative 1 plus 7x to the 1/2 power. Now we can use our power rule, constant multiple rule, and sum and difference rule to find what f prime of x is. We'll bring down the 4. 4 times 3 is 12, and then reduce the power by 1. In the next term, bring down that negative 1, so negative 2 times negative 1 is plus 2, and then reduce the power by 1, so negative second power. Last one, bring down the power, 7 times a half is 7 halves, and reduce the power by 1, negative 1/2. It might be helpful to look at 2 to the 2 times x to the negative second power is 2 over x squared, and 7 halves times x to the negative 1/2 is 7 over 2 square root of x. Because when we want to find our derivative when x is equal to 4, we got to plug it in. So we'll have 4 cubed, 2 over 4 squared, and down here we'll have 2 times the square root of 4. So 12 times 64 is 768. 2 over 16 is 1/8. And 7 over 2 square root of 4, well, that's 7/4. And once we simplify all of that, we'll be at 769 and 7/8, so 875. But that's our slope. Over here we have our point. So we have everything that we need to write the equation of our tangent line. We'll just do it in point slope form. Y minus the y coordinate is equal to slope times x minus the x coordinate. And there's the equation of our tangent line.